Assalamualaikum and hello everyone, welcome to a new video of your atomic radii. So in this video, what we're going to discuss is actually analyze the variation of atomic radii across the period and down the group, and then we're going to discuss and describe the variation of atomic radii across the first row of transition metal element. So first, let's look for the example itself. Okay, so here we're going to do the example. Here is a bit summary of what we have learned for the last video. Okay, so how to analyze the atomic size of element throughout the periodic table. First thing first, for a given so if they give you example or they give you an atom, first you have to write down the electronic configuration of your element, which in terms of your SPDF, and then check the n value, okay, the highest n. If n value is higher, it means that if the difference is actually the number of n, your highest principal quantum number, so we will be discussing in terms of NSAS. NSAS ni apa? NSAS tu in terms of our ni lah, in terms of our shielding effect. Okay, but then if you compare the electronic arrangement in terms of and then the number the highest principal quantum number is the same. So we're going to be discussing in terms of pizzas. Pizzas ni adalah apa? Pizzas ni yang apa ni, untuk ZEF, effective nuclear charge. Okay, so here again, remember that down the group ni means the same group lah, and across period ni the same period. So if the n value is different, then we're going to be discussing NSAS. So how do we mention it? First, mention the principal quantum number ataupun the number of electron shell increase. Okay, and then S ni in terms of shielding effect increase. So when shielding effect increase, what happens is that the attraction between the nucleus and the valence electron decreases and the size will increase. Okay, kalau across the period, pizza, bentuk dia pun macam pizza sikit kan? Okay, so what happened? The proton number increase for Pi ni. Z in effective nuclear charge increase, so it means that the attraction too is high lah between our valence electron and our nucleus. Hence, the size will decrease. Okay, so now let's look for the examples itself. Example number 1. Determine which one is larger. Explain. So we have our lithium or our sodium. So first thing first is check your list of constant. What is the proton number for lithium and sodium? So what happened here is that I have written down awal-awal dah. Okay, so here for lithium 3. Proton number is 3, while sodium is actually the proton number is 11. So kita check lah what is actually the difference. So dia kata check the n value. In this case is n equal to 3. Here is actually n equal to 3. N equal to 3, n equal to 2, ni n equal to 3. Okay, so when the n is different, so what we will be discussing is actually about our NSAS. NSAS ni ataupun kita tentang our shielding effect lah. Okay, so what happened? So we have to mention, okay, down the group. Okay, so Y group. So dekat sini, when n equal to 2, okay, yang ini kita dah belajar dalam 3.1 kan. So what does it mean is that, period dia adalah period 2, group dia is actually group 1. Kalau yang ni, period dia, period 3, where the group is 1. Okay. Again, period is actually based on your highest n. Kalau group ni, it's actually based on your valence electron. But kalau nak kira group ni, make sure determine whether it S block, P block or D block. Sebab kalau P block, plus dengan 10. Okay. So, here is actually for both of these atoms, actually the same group. Tapi the n is different. The number of shell tu different. So here how to explain it. Down the group, the n value increase. Okay. So which one has a higher n? So kita akan compare lah between these two ni. So dalam case ni has a higher n. So for this case is our sodium has a higher n, the number of shell than our lithium. So it means that our sodium ni has a higher shielding effect than our lithium. So when it has a higher shielding effect, so it means that it felt less of the attraction. So our sodium has a lower attraction between the nucleus and valence electron. Hence, the atomic size of sodium is larger than lithium. Okay, so again, because it's a question asked in terms of determine which one is larger. Okay. So next is actually it's either between phosphorus or magnesium. Phosphorus is 15 while magnesium is 12. Okay, so as we can see here, check dulu n dia berapa. So for both of these cases, n equal to 3. N equal to 3. So it means that for both of these cases, dia adalah period 3. Okay, so we can't use in terms of ansas lah. Kita akan tengok in terms of izas. Okay. Ini sengaja je nak division what is the group. Okay, so dalam case of our phosphorus ni adalah P block. So how to determine the group? Add in S, add in P, add in 10. So here is actually our group 15. Ni group 15. Okay, for our magnesium is actually S block. So just gonna take the electron as it is dekat S orbital. So here is actually group 2. Okay. So what happens is that this one is actually across the same period. So same period ni kita buat yang pizas. Okay, so what happened? Across the period, the proton number increase. Okay, so dalam case ni, which one has a higher proton number? Our phosphorus has a higher proton number than our magnesium. Okay, so it means that our P ni has a higher ZAF than magnesium. So you don't have to write down the calculation. Yang calculation ni tunjuk tu just to make it clearer to you. What is the effective nuclear charge? But then in terms of explaining, you don't have to written down or do the calculation. So the phosphorus has a higher attraction between the nucleus. So what happened bila the attraction dia has a higher attraction for the case of phosphorus, it means that the atomic size is smaller lah. Because it want to be closer kan. So closer maknanya small lah. But then the question wants it to be determined which one is larger. So which one is larger? So what we're going to do, kita buatkan lagi lah. So mana yang lagi larger? Atomic size of magnesium is larger than our phosphorus. Contohnya if you want to do macam, kalau explanation nak terus yang ini pun boleh juga. Okay. So that's for question number 1. Question number 2, 3 and 4, I believe you could do it yourself. Later I'm going to add in more question on quizzes lah. But remember, if anything, make sure determine the periodic, the proton number. Case of 3 dengan 4 ni memang Miss dah bagi. Okay. So now, after we have discussing the example, okay, example ni usually is between the same, it's either period ataupun group lah. Ataupun between the S block dengan P block. Usually that's the case. For kalau yang D block, yang tu kita akan belajar, which is right now, is for the variation of atomic radii across the first row of transition element. Okay, so here the first row of transition element is from group 3 to 12, from our scandium to our zinc. Okay, so let's look here. And then here is actually, okay, yang 21, 22 is actually proton number. Down here is actually our atomic size. Okay, so dia kat sini. So let's discuss the atomic radius of transition element. Tapi dia kata dekat sini, the atomic radius is constant across the period. So we have to discuss why is it constant. Sebab bila kita kata tadi macam across the period, sepatutnya makin lama dia makin size dia makin kecil lah kan. If based on here, across the period size dia is getting smaller. Okay, why it is constant? So let's look it together. So I have written down here is actually the first 3 transition element. Okay, so kita tengok dekat sini. So what happens is that across the period, electron is added to the inner 3D orbitals. But the number of electron in 4s orbital remains the same. So kita tengok kat sini kan. From scandium to vanadium ni, the electron on S is the same. Tapi number of electron on D ni masih lagi sama. Okay. Tapi kat sini I'm gonna write down lah. Pink ni is actually our valence electron. Yang ini is actually our inner. Yang ni yang senang sebenarnya valence shell lah. Ni inner shell. Okay, so here pun inner shell. So that what is meant by the electron is added to the inner 3D orbital. So kita tengok makin lama the electron on D orbital ni is increasing. Okay. bila kita tengok kat sini, so what happens that when the number of inner electron increase, what should happen is that the shielding effect pun increase lah. Okay, when the number of inner electron increase, the shielding effect increase. Okay, why? Sebab yang ini dia relate balik dengan our shielding effect yang ini. Kita tengok dekat sini Kalau yang ni sebab N dia berbeza, tapi it's the same case where the electron, maknanya kita tengok the number of inner electron ni yang makin tinggi. So, case yang lithium ni, I'm gonna write down. Lithium ni inner electron dia 2. Inner electron for sodium ni is actually 10. And our potassium ni 18. Inner electron yang ni this part. Okay. Okay, so dalam case yang ini tadi, so kita tengok kenapa kita cakap dia increasing. So here is matematik kurang. Okay, 19, sini 20, ni 21. So here is actually my number of electron, betul tak? Here is 18, here is 19, betul lah. Okay, so sepatutnya when the number of inner electron increase, the shielding effect increase lah. Tapi size pula. So bila shielding effect increase ni, sepatutnya size kita decrease. Okay, tapi kita kena tengok next pula. Okay, at the same time, across period, the number of proton increase. Pula. Okay, so increase. So, bila sepatutnya the proton number increase, kita punya effective nuclear charge pun increase jugalah. Kan? Macam yang kita dah do the calculation bit sebelum ni, tapi ni mesti nak buat calculation. Is that we know that when the proton number increase, ZEF pun increase. So, in this case, shielding effect increase, ZEF pun increase. So, macam mana ni? So what happened is that the effect of increasing shielding effect is cancelled out. Dia dah cancel out by the increasing ZEF. Sebab bila shielding effect increase, what happens is that the size tu sepatutnya it becoming bigger. Tapi bila ZEF increase, patutnya size ni is becoming smaller. Dia opposite. Make up your mind. Mana satu. So what happen is that it will be cancelled out. So what happen is that the atomic radius is not significantly changed. But remember, this is only specifically for the transition element. So transition element ni dia gabung yang kita dah belajar dua tu. Okay, so that's it for the apa ni nama dia? The variation of atomic radii. We have looked for the case of down the group across the period as well as transition element. If you be unsure, again, we're going to do lots of exercises lah for this chapter. Okay, so that's the end for this video.